This is a waiting train clock movement. It's used in large clocks, such as in churches and municipal buildings or factories. In a turret, maybe the clock would have 4 faces. And so this movement drives the clock, but it's not completely accurate. It's called a waiting train because how it works is that it runs a little fast. It runs about 5 seconds fast in each 30-second period, and it stops at 25 seconds, and it waits for an accurate pulse from the master clock at 30 seconds, and therefore it maintains an accurate 30-second time period. The clock is of the hip toggle type. This rather ingenious movement uses this small toggle here, and when the pendulum is doing its full sweep from left to right, the toggle just brushes over, but when the pendulum starts to lose power and the swing is shorter, it will catch on the little screw here. The dimple is called, on the dimple. It will catch it like that and provide an impulse to keep the pendulum going. The waiting part is up here. When the 25-second time happens, it raises this arm. When it drops it, it makes the contact. That energizes the electromagnet here, raises this arm, so the pole from the pendulum is now clear of the ratchet and the clock doesn't turn. When it gets a pulse from the master clock, the arm drops like that, very good timing, and the clock continues to turn for another 25 seconds. So we'll start the clock. Here you see the hip toggle. Sweeps past until the pendulum loses some momentum, and then it gets in a pulse to energize the pendulum. The clock here is in waiting mode, and the pole is clear of the ratchet wheel, and coming up, the magnet was just released, the arm dropped, and now the ratchet is being pulled by the pole. Just coming round to the 25-second moment again. It makes contact here. That energizes the electromagnet, raises the arm, and then it just released it again. The clock was made by Gents, an English clock company. It was called the Pulsonetic Waiting Train Movement. This is a master clock. It's built especially to provide the timing pulse for the waiting train. The clock is controlled by a quartz clock drive, and that interrupts LED to the photocell, which is on the right, every 30 seconds, quite accurately because it's a quartz movement. And the ratchet wheel here round one tooth every 30 seconds, and it also provides an output to the waiting train every 30 seconds. So that's the master clock.